It's a university that prides itself for breadth. We're a campus university, mostly just outside the city center of Oslo, but the law school remains in the city center, and most of the growth in recent years has been ICT, life sciences, and the medical campus. And from the 8 faculties at our universities, we have no less than 5 presented in this 1-hour session today. My home faculty is the Faculty of Mathematics and Natural Science, so I'll try to cover the core technology part of UIO, of AI activities at UIO. And then Dag, Natalie, Malcom, and Anders will fill in from their perspectives. My home base is the Department of Informatics. I was the head of department until recently, and I worry I haven't completely unlearned the urge to be proud of our department. It's a large department. It's the largest computer science department in Norway, with a staff of about 400, of which 90 are permanent scientific staff, faculty, about 2,500 students, and about 200 doctoral students, PhD students. And the department, like the university, is fairly broad. It ranges from traditionally core topics, programming, software development, formal methods, networking, newly created section for machine learning that has grown over the past 10 or so years, and a fairly broad section for digitalization, ICT, computer science at the interface to users' society. This may upset some of my colleagues. These are the research groups where I think it's most clearly that there are strong AI activities, obviously in image analysis, in the ML vertical section, in language technologies, in robotics, and in scientific computing and machine learning. Also increasingly in digital security, cybersecurity, and traditionally logic-based part of formal methods. And of course, AI is of growing importance for the department and the faculty at large. We're in a large, modern facility that until recently was the largest university building in Norway. And it's named, and I can't not tell you this part of our proud history, it's named after Ole Johan Dahl, who was one of the 2 Norwegians, professor at our department, who are credited with the invention of object-oriented programming. So the Simula 67 language was the first programming language to introduce notions of classes and inheritance, and that's part of the proud history of our department. Norway is a small country, now actually moving into AI, and fairly common way of organizing research and development in Norway is collaborative, bringing together relevant players. And I'll give some examples of such collaborative activities, many of them national centers like this one. So Visual Intelligence is a Center for Research-Based Innovation. That's one of the 2 funding schemes by the National Research Council, where a fairly large group of R&D partners and innovation partners receive funding from the Research Council over a sustained period of time, in this case 8 years, fairly sizable funding. And so here the sort of research core is the University of Tromsø in northern Norway, the Norwegian Computing Center in Oslo, right next to us on the campus of the university and the University of Oslo. And there, this initiative, this research and innovation initiative involves a number of public sector actors and private companies. Equinor is the Norwegian oil and gas and energy exploitation, so that's a large company. And the sort of research, the goal, the mission of this center is method development in deep learning for image analysis, applied in 4 different application domains: marine ecosystems, it's important for Norway; Earth observations, that's important for Norway; energy is important for Norway; and health, of course, is important for Norway. And all of these increasingly lean on deep learning for image analysis. And through this collaborative structure, there is a high intensity of joint research activity. Another example, National Center for Research Excellence, SFF, so the sort of twin model to the research-driven innovation that I just presented. It's called Integrate. It's actually the same 3 research partners. In this case, the University of Oslo is the coordinator. At the University of Oslo, there are 3 departments involved: the computer science department, the mathematics department, and medicine. And Integrate is more focused on foundational research, doesn't have the same focus on innovation and knowledge transfer. And its mission is to try and reconnect traditional, well, knowledge-based, logic-based modeling perspectives with machine learning and deep learning, and essentially refine models, architectures that can take advantage of what we actually know about the modeling domain. Some things we maybe don't need the model to discover on its own. For example, that there are very few natural languages that have more than one subject in a sentence, or the topological necessary properties of certain anatomic features. These we can provide as a knowledge bias into the machine learning framework, and then hopefully derive more efficient, more accurate, more explainable, and more sustainable, smaller and more energy efficient machine learning systems. The third example, my own field, large language models. In our department, there is a research group, the Language Technology Group, LTG, about 30 people, 5 permanent staff, who specialize in natural language processing, and for the past 5 years in language modeling. And that group provides a national R&D competence hub jointly with other national players, and focuses on resources and models, technology, and evaluation benchmarks, actually knowing what works well and what doesn't for smaller languages like Norwegian, the Sami languages, but also the smaller, well, the European languages that are not big languages. And through this group, we are involved in 2 ongoing EU projects: HPLT, High Performance Language Technologies, where I'm the technical coordinator, and this recent larger Digital Europe consortium, Open Euro LLM. And that's, of course, a sort of fascinating experience to participate in this consortium with 20 R&D partners, including the major Euro HPC centers and several companies. So this is Digital Europe, relatively high TRL levels, but the University of Oslo, through its Language Technology Group, participates also on the strength of the long history that we have in enjoying access to state-of-the-art, high-end supercomputing, high-performance computing facilities, both in Norway and through Norwegian involvement in the Euro HPC joint undertaking. So when this Lumi pre-exascale system was installed, it's hosted in Finland, but it's a consortium where Norway participates. When it was installed, it was the 3rd fastest supercomputer in the world, and from the start, even before it went into production, researchers at the University of Oslo gained access to 25,000 GPUs. That's the prerequisite to much current large-scale deep learning. And it was instrumental in getting, for example, our language technology group involved in these European partnerships. To wrap up, another collaborative effort, Marie Curie postdoctoral co-fund network is currently hiring its second batch of 16 international postdocs. And these are sort of sprinkled out between the computer science department, the math department, the centers I mentioned, visual intelligence, and integrate and further strengthen this development in artificial intelligence. That's what I had, setting up the landscape, and I think I'll just hand over to Doug to complement with a perspective from the digital domain.
Yes, let's see. Do you now see my screen?
Yes. Oh.
Good. Okay, so I'm Doug Haug from the Faculty of Humanities, and I'm going to give you an overview of what we do in AI at the Faculty of Humanities. I've put together a sort of catalog of the initiatives that exist, the research projects there are. Obviously, AI is a smaller component in humanities than in the sciences, but there's still quite a bit going on. I'll have to confess that for some of these projects, I know not that much, but at least I'm going to present you a broad picture of what there is, ranging from sort of traditional humanities, you could say, reflections on AI, to actually applications of AI in to research questions in the digital humanities. So let me see. So first, I'll present one of the strategic priority areas of the Faculty of Humanities that is called Humane, a humanities hub for the reimagination of AI. This is a network, more than a research project. It's being led actually jointly by researchers at the Media and Communications Department and at the Department of Informatics that Stephan just presented. And there are also scholars involved from cultural studies, rhetorics, and it is sort of very humanities-based project where about analyzing, critiquing AI narratives for a just and sustainable future, and sort of envisioning what AI could be, in a sense. Reimagination is actually a word I noticed that shows up in several of these humanities-based projects. So there's Humane, and there's another one also at the Department of Media and Communication, which is called No AI. It's on knowledge, belief, and trust, and how this is more of a media project. So it's concretely going into questions like how opinions are formed in an AI-infused digital media environment. So they do research on how AI will influence knowledge acquisition, misinformation, opinion formation, and again, reimagining how AI can foster informed citizens and providing a sort of alternative view of the often dismal view that many researchers in humanities have of AI. I realized from going through all these projects. There is quite a bit of work going on AI and ethics in the philosophy department. This is something also that obviously seen as attractive in the larger initiatives in the sciences. So things like Integrate, the Center of Excellence that Stephan just mentioned. And I think there is a perceived need for really understanding more about the ethics of AI. And there are in particular two UIO philosophers that have been involved in several such initiatives. So Integrate is the center that was already presented. There is this round of AI centers right now that are being decided by the Norwegian Research Council. And they involve our philosophers. And also we have external collaborations between philosophers and the Norwegian Peace Research Institute, and Norwegian Armed Forces, where there's a project on warring with machines, and they're looking into the ethics of obviously then of AI-based warfare drones that find their targets through AI, etc. So this is another area where there's a number of people. I put the most central names here because I understood that one of the ideas here is to be able to foster collaboration and so on. So if you see the slides and you see someone here you could contact, but obviously there are always more people involved, including PhD students, postdocs, etc. Then moving more into linguistics, there are several projects actually on communication with machines. So how do we communicate with the chatbots? This is a question that raises rather fundamental issues for traditional linguistic theories of meaning, and not least of pragmatics, which always involve reference to intentions, and it's not clear that these LLMs have communicative intentions at all. So there are like two strands of research within this field, the communication with machines. So one is empirical, in the sense that how do people actually interact with LLMs? So they're doing experiments, they're recording conversations with LLMs, but they're also trying to build a model of how communication works in this setting and how we actually are made to believe that LLMs communicate like us. And then and setting up, in a sense, a new theory of communication in that field. And then there's also, within this cluster of projects, there will be work, this is a very new project, there will be work on how LLM utterances are interpreted by developing children as they acquire language, and by individuals on the autism spectrum and on neurotypical adults. So, and doing comparative studies of how the interaction works. Then we have Ritmo. This is a center of excellence in musicology, and they have done quite a bit of work based on machine learning, and then recently, obviously, AI. They do deep learning for music analysis, automatic transcription of Norwegian folk tunes and of other kinds of music. But they also do generative models with audio input and output, and they've designed deep learning models that you can actually, in a sense, use as an instrument during a performance. That can work in real time in producing sound, and is, in a sense, governed by the performer. But also autonomous agents that co-perform with humans. And they developed a number of software libraries for that in that setting. So Ritmo is a center of excellence that is just now ending in musicology, and they have a new initiative for this round of AI centers, and that's called Mishmash. It's a proposed center on AI and creativity that sort of grows out of Ritmo that was focused on musicology, but involved people from outside musicology, visual arts, film, virtual reality, literature, performing arts, games, music, all sorts of creative endeavors. And they want to create a virtual national research environment for that, develop AI-based algorithms, and build expertise on how AI is used in the creative arts. This also involves what is called in Norwegian artistic research and development. So you can do a PhD in artistic development, like a performing musician. And they want to foster interdisciplinary collaboration from the sort of soft sciences, traditional musicology, into the hard sciences, including informatics. Then, finally, what I know most about myself is HUMIT. This is a new unit at the Faculty of Humanities. It's established as a Center for Digital Development. It consists of me as the academic leader and Professor Jakob Høygild, who's a professor of Arabic. But the team itself is technical. So there are 7 research engineers hired full-time to develop digital solutions for humanities research. Traditionally, we did a lot of web development and online databases to present research data that is being gathered by scholars at the Humanities. We had a strong focus on language data. But recently, we've seen a drift towards use of AI. Obviously, people are interested in linguistics. They want to have automatic transcriptions of their recordings. In literature, they want to have maybe analysis of large amounts of text, etc. So there's a lot going on, and we're refocusing our intention or efforts in that area. And we've done a number of projects there. So we do language modeling on a smaller scale and for even smaller languages in a sense. So we have now a project on BERT models for historical stages of Norwegian. So Old Norse and Middle Norwegian. These are being developed as tools in a project to annotate language data from those periods. We'll see how it works. It's a very exciting project where we do transfer learning across stages of Norwegian. We look at languages that are closely related, such as Icelandic, which is actually quite close to Old Norwegian. So that's one project. Then we have another project. There's this Center for Norwegian as an Academic Language called Nordbruk. And as part of that, there is a lot of effort going into creating language models that are usable for Norwegian as an academic language. Obviously, we rely here on general language models that are being published by the Department of Informatics and National Library, but they need sometimes to be specialized for academic language, for specific terminology, etc. And the same goes for the speech recognition models. So there was a large initiative at the National Library developing very good automatic speech recognition for Norwegian. But when I run those tools on my lectures on ancient Greek grammar or on logic, they often fail on the technical terms. And so we're specializing against those models to do ASR on academic language and on university lectures in collaboration with the IT department, who have all these recordings of university lectures. So that's another exciting new area for us. And then we also use LLMs, obviously, as tools in our machine learning approaches for doing part-of-speech tagging, semantic parsing, and various other projects. Sorry, this was Zoom, please, yeah. Okay, sorry, I was intruding into my office here. Final exciting thing we're doing now is image transformers for archival search. So this is a great project we had on the Ottoman State Archives. I have a picture here. You can see how the script is very convoluted, right? This is Turkish and Arabic script, and they write in all sorts of directions, in circles, etc. This is way too complex to be captured by OCR or HCR. So what we did to do search in these documents is that we trained a BERT type image transformer on hundreds of thousands of photos like that. You get a sort of foundation model that has a tokenization of these pictures. And then you can fine tune it to search for specific words, right? So we did this for a project on pest in the Ottoman Empire, and they need to find all the occurrences of the word pest in these documents. And so we fine tune it and then run it, and they find all the relevant documents, and the historians can look at them, which is great because these archives are enormous, and it takes quite a bit of time to read through all this text manually. That was the final project I had to present, but as you can see, there's for humanities faculty, I think, a lot of activity both on AI and also using AI on humanities problems. This is set to continue with new initiatives, but the challenge is, in a sense, to create this meeting arena between the technical expertise and the humanities researchers. And this is what we try to do in my group, Humit, but it's not always easy to reach out to two scholars and create those meeting points. So that's a big challenge for the future. So that was humanities. I'll stop there and hand over to, I think, Malcom, but I'm not sure.
Actually, it is Natalie Halvorsen who will tell us about AI-assisted diagnosis and treatment. You can do my moderation work. I have no troubles, but I have to respect the order.
Thank you. All right, here. So, hi guys, my name is Natalie Halvorsen. I'm a medical doctor and PhD fellow at the Clinical Effectiveness Research Group. They're a part of both the Health and Society of the University of Oslo and also University Hospital. So I have more an medical and epidemiological approach to the AI. So like what the actual effect of it is when you use it in the clinic. And so to explain what we're doing and what kind of prospects we have on future research, I just want to give a little bit of background on why we should focus on colon cancer. It's one of the few preventable cancers because of early diagnosis tools and good treatment options. And it's also the third most common cancer. You can see here that in Norway, we're actually one of the countries with the most colorectal cancers in the world. And a lot of other countries in Europe are also subject to this. With the age standardized rate of over 26.9 cases. And so we can prevent colon cancer by removing lesions in the colon before they actually progress into proper cancer, before it progresses into metastatic cancer, and before you will actually need any kind of chemotherapy or radiation or large surgery. We could remove it endoscopically as well with this kind of exam that I have marked here in red, which is called the colonoscopy, where you examine the colon with a flexible tool with a camera at the head so that we can examine and perform small surgeries inside the colon. So with this camera, you can also add on AI tools that have become available on the market. We have something called CAT-E, which can detect these precancerous lesions, and CAT-X, which can diagnose exactly the stage of development in this lesion. So it could be that it is way before developing into some kind of cancerous lesion, or if it's highly developed into a cancerous lesion. I can show you some examples here with the computer-aided detection. And this tool is necessary to use because, or the goal of using it is to find 26% of adenomas that we usually miss during colonoscopy. Because finding these requires a lot of training, a lot of patience, and time to perform the exam correctly. Here you can also see the computer-aided diagnosis, where you will use, sorry, the sound is a bit heavy, where you would use a magnification to look very close to the lesion and gain some kind of knowledge on whether or not it's cancerous or not. So if it's not cancerous, you can just leave it, and then you would not need to remove it and send it to histopathology and have all of these extra carbon emission procedures and costs. So it could be a very valuable tool to reduce the burden of a colonoscopy. However, are these tools actually beneficial? We know that patient important outcomes from interviews and general clinical practice is that they care about few things actually. They care about whether or not they will affect their risk of colorectal cancer. They care about whether or not they will have an adverse event and how many times they have to endure a colonoscopy, because it's not that fun to do. And the healthcare provider cares about other things. They care about whether or not it will be overdiagnosis and overtreatment. Do I do something that I don't need to do? Will it cost more? Will it have more carbon emission? And who's actually responsible for the care? Is it me? Is it the technological company? Is it the patient? It's a lot of factors that are difficult to know about when you start using an AI without a trial beforehand. So our project is called Opera, which is including a lot of different work packages, but I will only explain about a few. It's mainly about CADI. So this is an international collaboration with 17 institutions from 11 countries. This is from our startup meeting in 2022. And these are our key collaborators. If you have heard or know about any of them, they are a gateway to us and to collaborate with us because we do other projects as well with them. And the biggest study that we're doing right now, which includes the most amount of sites and the most amount of collaborators, is a study where we do AI in half of the colonoscopies and no AI in the other half to examine what the actual effect is. We have 47 centers across Europe, Japan, and Canada that are included, and we have included about 34,000 patients already. But the goal is to include at least 70,000 and hopefully 200,000 by 2027. And we'll see, because we have included all of these sites in the last 3 years, and now it will be like an exponential growth in the inclusions. And then with the results we have, we work with MAGIC, which is a guideline, a foundation that communicates with other areas of the world, such as the European Society of Gastroenterology and the American Society of Gastroenterology. And they work through the BMJ to produce guidelines. This is just about how they work. These are regular guidelines, but they have the goal of doing something called living guidelines, where you always have new evidence and can update the guideline continuously. And in that way, the reliability will maintain to be high when you can constantly update your guideline. And the funny thing is that with our research, we've shown some results. There's small actual reduction of colorectal cancer with the AI, but there are no additional harms. And with these results, all 3 societies that I cited earlier have actually gone and recommended 3 different things. So it just goes to show that even though we do data synthesis and communicate across cultures and backgrounds, everyone will take the same evidence and they might have different opinions. So no matter how technological or detailed oriented you are, they will still take the same evidence and use it for their population. So the BMJ, with their very much, how do I say it, statistical and methodological way, would advise against the use of AI, while the ESG, who are more pro the AI, would still advise for the use of AI with the same evidence, while the American Society will offer no recommendation because they don't trust the evidence that is available. So I think that we still have to collaborate a lot together to find the same the same way we want to use things. Anyway, the future of our work is to overcome potential issues such as over-reliance and de-skilling of clinicians with the use of AI. So we need to have more studies on the communication between the AI and the clinician. Also, we can of course evolve the AI devices by training it more and maybe making it better so that they will perform better, but that's another project. Okay, if you have any questions, this is my email here. Thank you.
Thank you very much. Now I will invite Professor Malcom Langford to tell us about AI in law studies and governance for AI.
Thanks very much for the invitation. I'm Malcom Langford at the Faculty of Law at the University of Oslo. I also collaborate with Integrate, Centre of Excellence, which is named earlier And I formerly directed a Centre of Excellence in Education, which had a strong focus on digital technologies and AI. If we go back 55 years, we were the second in the world to establish a research centre on law and computing. It was by the pioneer John Byng. And you can see in 1993 an essay, a set of essays on law and artificial intelligence, because not only was this centre looking at governing digital technologies, which began emerging particularly from the 1970s, but also using them to improve legal research and the justice sector, whether it's efficiency, the quality of legal decision-making and so forth. And we got the first wave of AI and law in the 1980s, particularly through rule-based approaches. And this centre today continues with Tobias Mahler taking over the directorship after summer, if you wish to contact him. However, as we all know from the Game of Thrones, winter is coming, and in general AI, we had the AI winter in the 70s and 80s, and law, it came in the 90s, where pretty much things stopped. But as we charted in a recent article, we now have a major computational turn in all areas of legal research. It began around 2010, 2015, particularly with new machine learning approaches, combining them also with classical approaches. And we now see an explosion in that area of legal research. One area where particularly started happening already from 2017 was at the Pluricourt Centre of Excellence for Research on International Courts. We built up a major database, for example, in international investment law, which concerns treaties that allow foreign investors to sue states for interfering with their property rights, for better or worse, a very controversial area. One of the things we did was, for example, predict in these decisions made by arbitration panels who actually wrote the decision. Was it the lead member? Was it the wings? Was it a secretariat? Was it a research assistant? Given concerns about this in the US Supreme Court. And we found great variations in the styles and across decisions, which suggested that some arbitrators actually weren't writing their own decisions. In another major project with Rune Lee, who's a leading data science at the law faculty, he built a database showing over 3,500 investment treaties, a network of all their clauses and how they were built up over time, which then allowed us to actually predict treaty outcomes between states with much more precision than, say, political scientists have been able to do with traditional measures like the GDP power of a particular state, which sort of raised questions about why states negotiate treaties when essentially we could predict the outcomes in advance. And given long historical structures and decision-making that was embedded in this dynamic network. Another thing we've done is to build up now major data sources for computational and AI-based work within legal research. We now have S2 Data, the research infrastructure for sensitive social data, which we'll be very happy to collaborate with Circle U researchers. It was firstly built around Nordasyl, which is a Nordforsk, Nordic Council of Ministers project, where we have in Norway 160,000 decisions and 4 million documents. We also collaborate with Sweden and researchers in Sweden and Denmark and Lithuania, where we now have up to almost 1 million asylum decisions. But what we've built is the ability to actually do machine learning on the original documents with personal data. If you want to, as a researcher, to read the decisions for qualitative or doctrinal matters, we're able to do that. But we've built it in such a way that you can actually do AI-based work on original decisions with all personal data. In addition, in the cleanup project with the Norwegian Computing Centre, which was named earlier by Stephan Oepen, we've looked at actually how you automatically anonymize unstructured data. And in that S2 data, we also are able to extract the data using cleanup methods for automatic anonymization. There's been a lot of work in this field, but also integrating it with the legal requirements under GDPR. Because one of the issues across Europe, including all the Circle U countries, it's only 2 to 3% of judgments are published online, which really restricts the ability to do AI-based work on law. And so we've done work with the Council of Europe and other researchers on how we improve the online publication of decisions and take account of GDPR, but also new AI Act requirements around the proper use of judgment data. And you can see there the performance of different states across Europe. The second area I want to move on to is AI in legal education, given the Centre of Excellence we had there on experiential legal learning. We have some courses which are specifically on using AI in law. Here, students work over a period of 3 months to develop a product to help citizens, judges, or lawyers use AI to improve legal services, legal reasoning, legal outreach, and so forth. And some of these projects have gone on to actually be used in practice. We have another course, Programming for Lawyers, where we teach lawyers basic programming. And given the arrival of large language models, we're now transforming that from next semester into a course on data science for lawyers, where they can also use LLMs to actually improve their coding and move more rapidly through to a higher level of coding competence. We also have other courses. We have actually 10 other courses which deal with regulation of data and AI, and perhaps the leading, most relevant course there is on robot regulation, how we govern the use of AI in cyber physical systems, whether it's health robots, driving robots, sex robots, you name it. And students there make a film on how one regulates these robots. We also have engaged in learning analytics with AI. We have, for example, one system that we've developed which provides automatic responses to practice essays that students sent in, a mix of rule-based and machine learning-based AI. Students have developed the Mørch learning tool for human rights practice, which not only builds on network science, enabling you to understand how 36,000 European Court of Human Rights judgments interact, but also integrates AI tools to help you quickly find the most relevant decisions, similar decisions, get summaries, and so forth. We also have, with the Team Learn project, developed analytics for group-based projects, where students automatically get data on, for example, who is talking the most in the group, who is interrupting the most, how the group is working together. Finally, the governance of AI, which has been the other stream of research, since the 1970s. We have some major externally financed research projects on this. We have the Digital Welfare State, which is looking at the digitalization and the algorithmization of the public sector, particularly use of AI for control, decision-making, communication with citizens. We have the Vulnerability in the Robot Society project, which is just finishing up now, looking at regulation of robots. We have the Digital DNA project, dealing very much with the intersection of biotechnology and AI. That project is at our Department of Criminology. We're one of the few faculties of law to have criminology integrated in a law faculty. And of the 11 researchers there, 7 work on emergent technologies and have major projects. And this is one of them, an ERC starting grant. In addition, we have the DigitalEdu project financed by the Research Council of Norway, looking at how to maintain ensure rule of law with digitalization. Across the faculty, we have around 30 researchers who work on different aspects of AI and law. One of our researchers, Lee Bygrave, the current director of the Norwegian Centre on Research and Law, is one of the editors of the GDPR commentary with Oxford University Press. We have many researchers looking at the AI Act, but also other relevant areas that regulate AI, such as human rights, a new report by Rebecca Blacker-Strand on issues around discrimination and fairness in AI, but also many working on different domain areas, whether it's intellectual property, competition law, labor law, platform regulation, archive law, There's a lot of work being done by researchers. And this also translates into policy engagement, where we've sat on various public commissions. For example, recently releasing a report on learning analytics with a whole series of recommendations for legal and technical reform. But we also have students very much at the forefront. In the subject called Lov Lab, which is a legislation lab, students write public commission reports as if they were sitting on these commissions themselves in the same format. They use 6 months to do this, and 7 of these reports have covered AI, and some have had significant impacts on legal practice. And lastly, we're also now starting to work more on AI for governance of AI. How can we integrate AI in how we govern this field? And one example is Erik Roseg collaborating with NTNU researchers on building a domain language for maritime regulatory compliance, in which you embed legal rules in AI systems in the maritime sector. And that was the speed date with the law faculty, and a marathon at sprinting pace, but I hope you've got a sense of what we've been up to for the last 55 years. Thank you.
Thank you very much. Okay, and the last speaker in this session is Professor Anders Mørch. He'll tell us about learning about and with generative AI.
Greetings. Let's see here. Can you see my slides?
Yes.
Perfect. Yes, I'm Anders Mørch from the Faculty of Educational Sciences and the Department of Education. We are one of the smaller faculties at UIO. We have 4 units, 3 departments, and 1 center. And I will jump right into it, one specific project. Actually, Malcom, you mentioned one project already we are involved in the area of learning analytics. But I will go into another project and describe, which is called Learning in the Age of Algorithms. Læring i algoritmenes tid. It's a project funded by the Research Council of Norway, and it involves 2 of our departments, Department of Teacher Training and School Leadership and Department of Education, in which I and my colleague Sten Ludvigsen are involved. And this is an innovation project, and it involves a municipality outside Oslo and 6 upper secondary schools in that municipality adopting AI for teaching in some of their classes. So it's quite interesting. So we are involved in studying this classroom use of AI technology, and we also training teachers to become competent practitioners of AI technology. And also some of the teachers are becoming end-user developers, by which means that they're adapting AI technology to specific subject domains, which we refer to as EUD or end-user development. Some screen images on the right-hand shows that we're working on generic GPT models, starting with 3.5 and most recently 4.0, adapting models to specific subjects. We are using educational research methods from the social sciences, such as case study, video observation, interview, and log data. So I will, like I mentioned, I will jump right into one specific project and provide some findings from that. First, the overarching challenge and dilemma, which most of us know. Well, we believe it's important to use AI in education, but it should be used in a way that do not deprive pupils from the cognitive processes involved in their learning activities. On the one hand, we see that it's very easy for pupils to ask Gen AI technology to provide answers to the assignments given by the teachers. But of course, they do not learn much from that. On the other hand, we see that teachers, being aware of that situation, wants the pupils to develop so-called generic skills, which are skills in order to learn about and use the technology and to manipulate the text in different ways, such as asks to simplify, explain, evaluate, identify the sources of the suggestions received, elaborate text, etc. And this tackles some of this challenge, but the problem is that it takes time away for teachers to focus on the subject matter, being math, biology, history, etc. So we have developed, or we have a conceptual framework in our research to help us to analyze data and to provide thematic codes for the coding of the data. One is autonomous versus assistive AI, and the other is different modes of interaction with generative AI. I will briefly describe those two aspects of the framework. Autonomous versus assisted AI. Of course, if adopting autonomous AI perspective, the computer will perform most of the intellectual activity in interaction with the student. The student basically provides feedback or prompts, and the AI would provide a solution, an answer to the question, or developing a text for their assignment, etc. Assisted AI would be the opposite. The student would perform most of the intellectual activity, and the computer will provide the prompts or the feedback back to the students so they can improve their texts. So we are trying to find different ways to combine these two different approaches in different ways to leverage AI, but also to be aware of the challenges. As mentioned previously by Natalie, it shows that some people are very skeptical to AI, others are more positive. So we need to balance those. And this is very, very easy to see in the educational setting. Modes of interaction with generative AI, that's the other aspects of our conceptual framework. One of our doctoral students, Henrik Schön, he developed a model for using Gen AI in education based on our preliminary findings from the project, distinguishing three different modes: learning about Gen AI, learning with Gen AI, and learning through Gen AI. Gradually moving from learning about the technology towards using it for developing generic skills, I mentioned before, and to assess different ways to use AI for critical assessment of text produced, etc., to using AI more invisible. The technology becomes invisible when you're able to focus directly on a specific domain, a specific subject, a specific interest, a specific problem of inquiry. Of course, we like to go to the last stage, but it's very challenging. So we are moving down those stages, and we have example to show how the teacher go about addressing this. So I will now at the end just provide some examples from our data, which are interview data with students in the project, or also interviews with the teachers we used. And this is a teacher that was asked the question by the researcher, and the teacher is a history teacher. So I just have to move this. How much emphasis did you place on the subject of history in this setup? And the researcher is referring to the last social studies class for this 8th grade class in this municipality. And how much emphasis did you place on critical source analysis as a generic skill? The teacher says critical source analysis was probably the most important part, that the students should receive an introduction, a sort of crash course, but being critical sources is important. It's something they must do. It's not so important that they grasp the World War I part, which this course was about aspects of World War I history, showing that the teacher puts a major effort on the generic skills, not having proper time to develop the domain-specific skills in this case. As a result of the pupils using AI to help them writing an assignment. Let's see, move on to the next slide. This is another example from one of our master students who did interviews of a teacher teaching with AI in the mathematics class, where they also used programming in Python to help them to solve problems. So they used a chatbot called Cody, developed in the project. The interview asks, do you think he could function as a sort of teacher? And a commentary is by he meant Cody, the chatbot the students used in the math class. And the student says, but one thing I'm a bit worried about, he might not explain how to solve the math problem. He might just give me the answer. So this is an example. The student was a little bit worried getting answered too quickly, not enabling him to solve it through a process. So having a chatbot as scaffolding enables tasks that previously was not possible for the students, and the teacher thinks also this is useful for the students, helping them. But to use the chatbot efficiently is crucial to realize their learning potential. And sometimes students find it frustrating to use AI in classes because sometimes it deprives them from the process of gaining the solution rather than just getting the answer, learning less from that. So the student needs sufficient knowledge and experience to use the tools effectively. What's something we learned from these interactions with the students. And also, this could impact their learning in the long run in negative ways. So this is part of an ongoing project, as I mentioned at the beginning. So we look into students' learning, students' use of AI, and the teachers' use of AI. And we found that the teachers focused more on domain-specific skills when using AI, but sometimes they took shortcuts that deprived them on learning opportunities, as I just shown in the example. So that requires proper training in the use of these types of tools. And the teachers, to circumvent that problem, focused more on generic skills for how to use generative AI, because they found that this advanced technology could deprive them of important learning opportunities, which is very different from previous educational tools that have been used in schools or from a long time before. And they don't want their students to take shortcuts. So these are some preliminary findings from the Learning in the Age of Algorithms project, which is an ongoing project. So I will stop sharing.
Thank you, Professor. And I would like to thank you all both for your exciting presentations and for your punctuality that made my job of moderation quite easy. So now is an opportunity to ask questions, either from the audience, which can ask questions through the chat, or from the panelists. Okay, maybe I can. Oh, here it is, Professor Francesco. Yes, please.
I just open the question. So I would like just to thank very much all the speakers because really they gave an idea of the research activity inside the University of Oslo. And I'm very, very happy about what we really listened during this presentation. And I also can observe that most of the research activities are really developed probably also in the other university. And I think that's really we can create some connection with the other universities. And there are some interesting aspects. I just listened the last presentation about this relation between generative AI and education in general. This is, I think, it's a very hot topic in the CircuitU community, in the CircuitU Alliance. Also, we were invited by the rectors just to make suggestions about the use of generative AI on education. So I strongly believe that we have just to create a focus group on the knowledge hub on AI and education And I just invite Professor Mørch just to really be present in this focus group if it's possible, because I think it's this experience is very, very relevant. But I think that we have other experience in the other university. Also, the contribution on AI and law and AI in medicine. I just listened about networks, and the other question is how much really the university and the CPU are involved in these networks. And this, I think, it's an opportunity just to open also to the university in CPU this opportunity if it's possible. So I'm very happy about this presentation, and I like it a lot. Thank you very much.
I'm happy to be part of this focus group, Professor Marcoloni. Please let me know when the meeting will be.
Thank you very much.
Professor Malcom, please.
Yeah, just two quick comments. Firstly, on existing collaboration. So we do have some collaboration with King's College. In fact, the Mørch group who developed the human rights analytics just got some funding from Circle U to visit King's and work with some of our colleagues and fellow students there. Vienna also has a strong program in law and data science, but there could be others, so it'll be interesting to hear. A real game changer will be the AI centers that were mentioned by a number of speakers. At the law faculty, we're involved in two. One of them is Trust, and the other is NCLM on language technology, which Stephen was quite involved in. I mean, Trust has already 30 research partners, national and international, and is quite broad and includes a lot of focus on AI, governance of AI, but also AI for governance. We don't know if we're going to get these two centers. There's 3 or 4 centers which are coming out of the University of Oslo, which have got good chances. But I think if we get those, I think there should be a conversation that comes afterwards about the possibilities for those. We propose, for example, creating a new national alliance of AI centers that could also give a lot more energy to also international collaborations. Thanks.
Thank you.
Okay, we have time for maybe one more question or comment. Professor Stephan Oepen.
Yeah, it's more comment. I felt like maybe elaborating a little background because it came up in several of the presentations. So the Norwegian government about a year ago decided to create a major investment in AI R&D and earmarked 1 billion Norwegian crowns, which is about 100 million euros. And then there was the nation went AI crazy. 120 proposal outlines were submitted, 50 full proposals, and many of us are involved in 1 or 2 of them, and 6 will be funded. And we'll hear in about 2 weeks, and this will be sort of a very nationally an important decision point, because then AI activities at the University of Oslo, but also in collaboration with other Norwegian universities, will know the structure moving ahead.